Hi everyone, my name is Luis Gonzalez from Group 1 of the Advanced Malware class. Today I'm going to be doing a quick demo of how malware propagation in containerized environments. So before we get started with the demo, I just wanted to go over the lab topology. And here we can see, we'll start over here with our Docker 1. This is an Ubuntu server that is running the Docker software, which is used to manage and create the containers. Here we have the default network that's assigned to the containers. It's 172.17.0.0/16. Inside the containers, the container environment, we're going to be deploying two containers. One is going to be a database, and it's assigned with a .2 IP address. The other one is the web server, which is assigned with a .3 IP address. As you can see here, we have a port mapping, which is going to be used to translate the connection to the front end interface of the Docker 1 server, and it's going to be mapped to the port that is actually listening on the web server. So when we initiate the container for the web server, you will see that on the front end IP address of the Docker server, it's going to be listening for port 8001. And when we send the connections to it, that connection gets translated to port 80. Over here, we can see that the front end IP address is connected to the DMZ network. This DMZ network is segmented by a firewall, and the firewall is connected on EM to the internet. And on the other side of the internet, we have our hacker here that's running Kali VM, and we're going to be using this machine to break into the container environment. What we can see here on the firewall, I want to point out too that we have an inbound rule, which is allowing any IP address, so simulating connections coming from the internet to a web server. Any IP address can connect to Docker 1, which is going to be the 201.148 IP address, over port 8001. That means that there's, we will do a scan on this interface here, and we'll see that only Docker 1 with the IP address with the port 8001 is open. So this is the only door that we have to get into all of this environment here, okay? So now that we have an understanding of the lab topology, let's go ahead and jump into the command line. Okay, so the first thing I wanted to point out is that we're here at Docker 1. So this is our Ubuntu server that's running the container software. And the first thing that I want to do is let's go ahead and list all the containers that have been deployed already. And what we can see here is that we have one container, and if you look at the name, it's a dvwa underscore db name, which is the database server, the database container that we deployed. And there's nothing else deployed so far. And the other thing I wanted to point out is that over here in ports, there's no port mapping, okay? So basically what that means is that from outside the containerized environment, you cannot initiate any connections to connect to the database. So it's basically unreachable from outside the containerized environment. Okay, so let's go ahead and take a quick look at the database. So this is the database that we have, for the database container that we have. So you can see the name here, dvwa-db. So if we do a quick show databases, we can see that we have an FIU underscore lab table there. So if we do show, let's go ahead and jump into the database, use FIU lab, show tables. So we have a users table. So if we do select all from FIU underscore lab users, we can see that we have a table here with users. We have our first names, last names, usernames, the passwords, and a little avatar. Okay, so just wanted to show you that the database is working. Okay, that there's a table in there with some entries on there. So the other thing that I wanted to go ahead and show you is we're going to go ahead and verify the IP addresses that have been assigned so far. So if we run this command, you can see that from the containers we have 0.2, which is assigned to dvwa. Okay, so let's go ahead now and initiate the web server container. So give me 1 second. Okay, so we're gonna run this command here. So what we're doing here is initiating the container. We're giving it the name dvwa underscore web. And like I mentioned earlier about the port mapping, so we're mapping the port from the external facing interface to the port that is listening on the container. So let's go ahead and run that. I'm gonna pause real quick while it finishes setting up. Okay, so now that we're back, the server is set up again. Let's go back real quick and do some more checks here. So let's go ahead and check again the container. So now we have a second container. It's been up for about a minute, and you can see here the port mapping. Okay, so that's very important. If we run this netstack command here, we can see that on the front end of the server, we're listening for port 8001. So now that we have that set up, let's go ahead real quick and let's go ahead and get started with breaking into the containerized environment. So here I have one Kali machine that we're gonna be using to test. Okay, so the first thing I'm gonna do is just gonna go ahead and do a quick scan just so that you can see from outside that we only have one port open. So with this mmap command here, I'm scanning the first 100 ports and then ports 8000 to 8005 on the Docker server, okay? So this is just to verify that only 8001 is the only port that is open. And now that we know that that's the port that is open, let's go ahead and test that we can get the web page from that container. Okay, so when we run this command, we can see that we're getting the login page from the dvwa web application. Okay, so all of that is good so far. So what we're gonna do now, real quick, is just gonna open up a page, a web page, and we're just gonna go directly into the server. Okay, so we're connected to, this is a Docker 1 server. We're connected on port 8001, and we are the dvwa login page. So let's go ahead and log in. Okay. So the attack that we're going to be using to break in is just a simple command execution. So let's go ahead and set up the listener. So we're just gonna set up a listener on port 4444. Okay, so now we'll go back to the session. Okay. Okay, and we're just gonna paste this command here. This all it's doing is just basically giving it an IP address, because the command here says ping for free, enter an IP address below. So we're just giving it an IP address to ping, and then adding a netcat command to launch a shell, to send the shell to the listening device that we set up. So once we hit submit, we can go back to our command line, and we can see here that we are connected. So if we go back real quick, just so you guys can follow me. So right now what we have done is that we have broken into the web server. Okay, so we cannot, from outside the internet, we cannot connect to the database, but we have broken into this server here by accessing this port. Well, let's go ahead and go back. So now what we're gonna do is that we're just gonna break into the database from here. And the first thing that we're gonna do is just get a better shell. Okay. And then from here, what we're gonna do is we're just gonna do a quick nmap so that we can scan um, that network for the container so that we can see what containers are available. Okay, and we start seeing already that we have host.1, and this is the IP address of the Ubuntu server, and we have IP address 17.0.2 and 17.0.3. That's all we have gotten back so far. Let's wait for it to finish scanning. Okay, so now that the nmap has finished, we have 3 IP addresses here. This is the IP address for the Ubuntu Docker 1 server. And this is another container that we have. If we do ifconfig or IP address, we can see that that 3 is our IP address. Okay, so that 3 is our IP address. So that 2 must be another container. Okay, so what we're gonna do now is just check the ports on that. We're gonna do another nmap and just check the ports. We're specifically gonna be checking for port 3306 to check that it's a database. Okay, and with this nmap command that we're just checking for port 3306, we can see that 3306 is open, and that is the database, the port for MySQL database. And what I just want to point out with by running this nmap command is that from inside the container environment, we are able to scan for other hosts. We're able to see other containers that are available to us. And we can even do an nmap and see all the ports that are open and available. And we can see that from here, this port is open and available. So what we can try to do now is just try to go ahead and see if we get lucky and sign into the database and connect to the database and sign into it. Okay, and we were successful in connecting to the database. Okay, so we have the database, as you can see here. I specified the host for this host over here that we have available. And now what we can do is we can just go snooping around here and see what we can find. And we can see that FIU lab. So what we have done so far, just do a quick recap, is from here through port 8001, we were able to break into this web server here. And now from the web server, we have jumped onto the database, and from there we can, go ahead and do all kinds of things, spread malware. What I wanted to do here is just show you that we can even look at the database, at the table that we have set up. We can see the users. We can even break into it or insert into it. Okay. So if we do another select. Okay, so from the remote session that we have, the reverse shell that we established, I was able to go ahead and put an entry in the database. And if we go back to the database over here and we do another select, you can see the entry there. And then the last thing that I wanted to do is just drop database FIU lab. And if we go back to the database over here and we try to select, there's no more data. There's no more FIU users. Okay, we were able to drop the database. So that's pretty much all the demo that I wanted to show you. In here, in this demo, we were successful in breaking into a container that's accessible from the internet. And from this container, we can jump and spread malware to anything that's behind this Docker net, unless other security measures have been taken to prevent such connections.